So tonight we're going to call this Notes 11-3 Part 2. And we're going to put today's date on it. (2/12). Fill in your page number. We're going to slip this in after Notes 11-3. And we're going to do a review and a writing the equation of a line. So take notes as much as you can. Write down any questions that you might have so that we can answer them tomorrow in class. Follow the steps written on your outline of notes. Anything that you've had previous to this. We did some examples on page 361 and 362 that go along with this also. So part 1, let's review the slope formula first. Finding the slope of a line given the 2 points. And if you recall, the slope formula was y2 minus y1 over x2 minus x1. And it's on our reference sheet that the Regents gives us for the exam. And each of these, I call this first one point 1, and it's always in the form x first, then y. And then I just call this one x2, y2 because it comes second. So this is my second x and my second y. And now I go through and I substitute my values. I say y is 3 minus the other y, which is 2. And then I have to be consistent, so I go back to this one here, this -1, and I subtract a -4. And because I have those double negatives, I'm going to fit. 3 minus 2 is 1, and a -1, which is really now plus 4, is a positive 3. So the slope is 1 over 3. And that means that we're going to rise 1 when we are on a graph, and we're going to run 3 spots. So let's try that one more time, except now we have 2 new points. We're going to find the slope of a line given the 2 points, 6, -4 rather, and 2, -8. Again, this is my first point and my second point, and that's just because that's the way they're listed. If we wanted to get very mathematically technical, it would be how they're plotted on a graph from left to right, because that's how we always read a graph. But we're going to stick with this consistency that the first point is our x1, y1, and the second point is our x2, y2. And here's our formula that we want to know, but we do have on the reference sheet. And let's substitute the values that we have here. So we have a -8 minus a -4. You got to be careful with those negatives. And then we have 2 minus 6. That double negative, we will cancel out. We have a -4, and 2 minus 6 is also -4. It simplifies to a +1. Okay, part 2, again, review. We have m and b, so write an equation. So given the slope, m equals -2, and the y-intercept, which is our b, at -1. So m equals -2, b is -1. Not much work to show for this. Write the equation of the line. It's y equals mx plus b. You never, when writing the equation, you always have to have your y and your x in the equation. And you basically just fill in the value for m and b. And so the slope is -2, so that's y equals -2x plus b. And in this case, b is a -1, so I can put it in that way. Or it can also be written -2x minus 1. So both of these being your answers, and if you graphed those, you would have an equation of a line on a graph, a straight line, a linear equation. Let's try that one more time. We are given the slope and the y-intercept, and we're going to write an equation. So we're looking to have m and b, and we have y equals mx plus b. And y equals, now we have 2/3 for my slope, x, plus b, which is 6. And there's our answer. Part 3, given a point and a slope, graph a line. Another review from the other day. Given the point 3, 4, and a slope of 1/2. So we have the point 3, 4, and m equals 1/2. That means we're rising 1. And we are running 2 spaces. So let's graph the line. Well, I start at the point +3, +4. From there, I rise 1, and over 2, and I make a new point. Now, when we get into more of the graphing later this week and after the break, we will graph more than just those 2 points. I like to have a few points, so that means I like to even work backwards on my line and get as many points as possible to fill up my graph paper. And then you, of course, would be using a straight edge. This program doesn't allow me to do that, but that's a pretty straight line. And so there we have the point 3, 4 with a slope of 1/2. Let's try that one more time, and at any time during these slides, you could pause me and you could try the question yourself before I go ahead and answer it. Given the point 0, -3, and a slope of 5. Now, 5 does not look like a fraction to me or a ratio, so I know I'm starting at 0, -3, which is here, and I know that the slope is 5, and I know that I can put any whole number over 1. So now I have my ratio of rise 5, run 1. And so from this point 0, -3, I'm going to go up 5, 1, 2, 3, 4, 5, and over 1 to put my new point. And I'm going to do that one more time. 1, 2, 3, 4, 5, and over 1. And so now I have 3 points for my line. And I'm going to use my straight edge, my imaginary straight edge, to draw that line. And I am going to extend this question one further. If I am at 0, -3, that is also the B value, my y-intercept. It's where my graph is crossing the y-axis. And so if I were to write the equation of this line, which we are getting into next, I have y equals the slope, which is 5, so 5x, plus the B value, which is -3. It's that value right there that crosses the y-axis at -3. So the equation of this line that I have just graphed is y equals 5x plus a -3, or y equals 5x minus 3. So part 4, which is a little bit of newer information, given the line, write an equation. So here we have a graph, and we have a red line plotted on it, and it gave us the 3 points. And if the 3 points weren't there, we could just mark those 3 points with coordinates or ordered pairs that we see. And so step 1 says, given the line below, find B. Well, I can see that B is right there, and the value there is B equals -4. Now, find M as the rise over run. So from that point, I am going to count up 3 and over 1. And again, up 3 over 1. So since the slope is always a constant rate of change, that's going to continue 3 over 1. So the slope is just M equals 3. Now it says write an equation as y equals mx plus b. So y equals m, which was 3x, plus b, which would be plus a -4 or just a -4. And that line that they showed us the original graph of is the equation y equals 3x minus 4. Let's try that one more time. I am going to do one more example after this one, so if you want to try this one on your own, that's great. And so pause me, find the equation of this line, follow the steps. Here we go. So finding B first. B is right here at the coordinates 0, 3, and we have the B value as just a positive 3. From there, I'm going to count my rise over run, but really I'm not rising. This line has a negative slope. It's going downhill. So my slope starts off with a negative number. Down 2, it looks like. Down 2 over 2. And let's see if that happens again. Down 2 over 2. And that simplifies to -1 over 1, or just -1. Now it says write our equation as y equals mx plus b. So y equals m, which is -1, x, plus b, which is plus 3. So the equation, or the line, has this equation, y equals -1x plus 3. our last example might be a little bit of a challenge for you. From previous knowledge over the last few days, you can see that this line is horizontal, and if you look back in your notes, we did say something specific about horizontal lines. They do have a certain type of slope, and the slope of a horizontal line is 0 because there's no rise. And so we're going to have 0 over 2 or 0 over 4. The bottom number, the denominator, doesn't matter. The 0 takes precedence, and we just have m equals 0. But it looks like this line is crossing at a value of 5 at the y-axis. And so very simple, we follow these steps. Y equals m is 0, x plus our b, which is 5. If we want to clean this up, you would say that, well, 0 times anything, 0 times x, 0 times 1, 0 times anything is 0. So this is really obsolete. We don't need it. And so we have just a leftover y equals 5. And that is the equation of that line. I call them special lines, verticals and horizontals. This is a horizontal line at y equals 5. Crosses the y-axis at a value of 5.